Hello everyone. In this video, I will guide you through executing SQL queries on the London Fire Bridge database and visualizing insight using Tabula. We will analyze fire incident, identifying high risk areas and evaluating emergency response time and a great start. Let's start with task 4. So our first query is returning incident data. So basically in this query is retrieving all records from the incident table. It helps out us to understand the data set structure, including columns like incident type, borrow data, response times, and many more. So basically, this query gives us the recent data which happens in incident time. Our second query it is filtering fire incidents. So in this one, since the database contains different types of incidents, these queries focus on fire related cases. This allows us analyze fire patterns separately from other incidents. So in this one, we select the incidents and we put where incident type, which is fire, which gives the result as like different fire related cases, which we can use it for further studies in future. Third query is total incidents by borough. So these queries group incident by borough, counts them and sorts the result in descending order. It helps us identifying which areas experiencing highest number of incidents. So like in this query, we select the borough count as the total incidents, and like from incidents group by borough ordered by total incidents dash, which will give you the descending order of the experiencing highest incident in a borough. So we can use these in the different areas to count the highest number of incident happening in different areas. Our fourth query it is monthly incidence trends. Here we extract the month from each incident's dates and count accuracy per month. The result helps us to analyze seasonal trends such as whether fire are more frequent in winter or summer. So in this one, we select the month incident date as a month and count as an incident count from incidents group by month incident date and ordered by month, which help us to show that in which season more frequently the fire incidents are happening over there. The fifth query it is most common incident type. In this query, the group data by incident type and count accuracy to determine the most frequently incident type. It helps service focus on the most common emergency. So in this query, we select incident type, count as frequency from incidents, group by incident type, ordered by frequency desk, which help us to determine the most frequently the incident are happening in which area, so like they can be prepared for further emergency. Other in this query, calculate the average response time per borough. Sorting it in the ascending order helps identify which borough have faster or slower emergency response. Select by borough average response time as average response time from incident, group by borough ordered by average response time as. This will help us to calculate the average response time, which help us to manage further emergency situations. Now we are moving to task 5, tabular visualization. After executing the SQL queries, we are used tabular to create insightful visualization. In this one, like tabular to create insightful visualization, these charts and maps help us to understand the patterns, identify high risk areas, and improve emergency responses strategies below determined of visualization. Incident distribution map. This visualization presents a geographical map of London, plotting the location of reported fire incidents. By visualizing incident spatial, we can identify the clusters where fires occurs frequently. This is useful for the recognition high-risk areas and assisting local authorities in resource allocation. Second is borough-wise incident chart. In this chart, bar chart is used to show the total numbers of incidents reported in each borough. Boroughs are ranked in descending order based in incidence frequency, making it easy to see which areas experiencing the most emergencies. This helps in identifying areas that requires better fire safety measure or increased emergency response service. Third graph is monthly trends line graph. In this graph, a line graph illustrates how fire incidents over different months of year. By analyzing these trends, we can determine if certain seasons have a higher occurrences of fire. For example, more incidents in winter due to heating equipment usage. These information are crucial for planning fire prevention campaign and for resource distribution. The fourth is incident type pie chart, in which a pie chart displays the proportion of different types of fire related incidents. It helps us to understand the most common emergencies, whether they are house fires, electric fires, or industrial fires. This knowledge aids focusing prevention measures and safety education on the most frequently fire hazards. Fifth is response type heat map. A heat map is used to visualize the average response time of emergency services across the different boroughs. Borough with the faster response time appears in one color, while those with slower response is highlighted differently. This helps in identifying areas where emergency response need to improvement, ensuring the resources are strategically deployed to enhance efficiency. Conclusion: by combining SQL queries with tabular visualization, we gain a clear understanding of fire incidents in London. These insights help us fire department and city planner make a data-driven decision to improve the safety, optimizing emergency responses, and reduce fire-related risk. Thank you.